Hello, everyone. Thanks for joining and welcome to another session of our Day One and Beyond series, where we take you through various topics and activities related to building out on Oracle Cloud. Our today's session is the Oracle Cloud Security Quickstart, where we will cover various security features and services offered by OCI to secure your Oracle Cloud workloads. So we will cover how security is built into each component of your cloud environment, and will also focus on the different tools you have at your disposal to improve your security posture. I'd like to introduce Winnie Yang and Snell Jane, cloud engineers on the customer enablement team, as the main presenters. And with that, I'll hand it over to Winnie to get us started.
Thanks, Olivia. Hi, everyone. My name is Winnie, and I'll be taking us through the first half of the session so we're going to go into security of the cloud, what that encompasses, and then also security in the cloud, what is available to you. So we'll go over identity and access management, detection, infrastructure, security, data protection, and how you can respond. So this slide might look familiar if you've joined any of our other sessions so far, but this is just an overview of all the cloud services that OCI offers and kind of, which section they belong to. So today we are focusing on governance and administration, most notably, the security section right here, but also a little bit on cloud ops as well and how it also plays a role in your security. So we are starting off with Oracle security principles. So what does Oracle strive to accomplish for our customers when it comes to making security easier? We focus on 5 things. So we have first one being ease of use as a high priority. We know that, we have to make your lives consistently easier, and ease of use is hard to add in, after you develop solutions to problems. So we like to just think about that ahead of time when we're building out new features. Next, Oracle Cloud does try to provide customers with transparency. We call this always on security posture with integrated controls. Secure shouldn't be a construction project. Next, we have prescriptive. So we believe in providing preventative guardrails that help reduce the chance of human error. That being said, everyone does make mistakes, so a safety net is almost always a good thing. Next is automation, and this is a key theme across Oracle, and it's certainly true in the domain of security. We want to automate as many routine tasks for you as we can, and enable customers to spend time on higher level issues instead. Last but not least, unification between tools and controls, just to make everything easier. So Oracle Cloud Security tools are available within the integrated OCI console, and ease of access and integration only means that, you just need to look in one place for your answers. So another slide that might look familiar, but this one is just showing you the differences in responsibility between the customer and OCI. So again, we are focusing on infrastructure as a service column right here, and we have about half of that under the customer responsibility and half of that under OCI. All right, so going into OCI compliance programs. So we have a lot of different certifications and compliance options across different industries, different regions, or even government sectors. This slide is really here just to show you the variety of programs that we offer. So how does it all kind of tie in together when it comes to security? So it really starts from identity, which is located on the left-hand side here. So we've covered a little bit of identity in our other previous sessions, But this is really the foundation because you really need your users, groups, and policies in place. And once you do have that, security is very important in OCI, and we'll be covering, some of that, some of those different tools in OCI to secure your resources and environment under monitoring and prevention here. So the first tool that I'll talk about is compartments. So this might be, again, something you remember, but as a refresher, I just want to, talk about how compartments play a role in this. So compartments, again, they are a logical grouping of related resources that can be accessed only by groups that have been given permission by policies. So it's really important to just make sure you have a structure built out for your compartment design layout, because how you build out your design layout is how you're going to attach your policies. So that's a super important aspect of building out your compartments. And so based on our example here, we have our root compartment, and then we also have a couple of child compartments. So we use different layout designs for our compartment structure, but what I wanted to focus on is that, you can mix and match different layout designs. So we have department layout design here. We have info services, marketing, finance, to keep that secure, so that the finance people only access finance resources, marketing only accesses the marketing resources, and etc. And within info services, we have a setup based on resource allocation. So the people who need to access infrastructure resources, they will only be able to do that because of this compartment design layout right here. So this is with our resources kind of added to our compartments. And you can see here, based on the policy placement, certain groups will have certain access to the correct compartments. So next, also kind of diving into a service that we talked about earlier is IAM identity domains. So Oracle recently merged IDCS, which stands for Identity Cloud Service, into the OCI native IAM service, or OCI Identity and Access Management. So the updated service is called OCI IAM, as you can see here on the slide. It's now a native OCI service available in all of the Oracle Cloud regions, and it's now better integrated with other OCI services, such as logging and CloudGuard. It adds all the IAM features and functionality from IDCS that you might have previously experienced into OCI. So features like strong multi-factor authentication, or MFA, context-aware adaptive security, identity lifecycle management, all of that and more are now in one place in the new IAM service. So as part of this new service that we are introducing, we've also introduced a new way to manage instances that we're calling identity domains. So identity domains provide an easy way to create and manage identity as a service instances directly from within your OCI console. So what this does is it creates a single unified IAM service that is able to address many identity use cases. So it could be managing access for employees and workforce, partner or consumer-facing apps, or IAM for custom app development. And with the correct backend and the right architecture setup to serve as our foundation for growth in the IAM space. So Sunil, before I move on, I wanted to ask you a question. How do identity domains keep your users and resources secure?
So identity domains are almost like an additional dimension to IAM, whereas originally you would have a tenancy, your compartments, and you would have your administrators for the tenancy, and you would create your different hierarchy. Now, with identity domains, you can have subtenancies. So let's say maybe you do an acquisition and you want to have one subtenancy for the acquired company, one main tenancy for the original company. You can keep isolation between those groups at a different dimension.
All right, thank you, Sunil. So we'll dive into a little bit deeper now of identity domains. So in more detail, these identity domains are able to address the needs of OCI, Oracle applications, and also third-party apps, which could be SaaS, running in the cloud or on-prem. And so by using identity domains, you do experience benefits, and that includes easier identity service management and configuration. So instead of setting up different IDCS instances and having to manage them outside the console, they'll now be converted into identity domains accessible via the OCI console. And you also get an improved OCI experience. You're able to have a single entry point. And then last but not least, you have numerous options for multi-factor authentication. MFA is enforced with identity domains. So next, we'll talk about authorization, which is basically policies in OCI. So Sunil, what do policies prevent from happening in your environment? How does it act as a guardrail for your resources?
So policies are kind of the general basis of everything on your tenancy. When your tenancy is created, there's one user who has policies to do everything. And then, after that, everything that's created by that user is completely locked down to all other users. So policies are how you give access to anything in your tenancy. If you create any resource, any compartment, it's all locked down until you have a policy giving that first line of access.
Yep, exactly. So policies are super important, and we'll talk about it in a little bit more detail on this slide and the next. So starting from the beginning, policies, you'll need a couple of components to actually create a policy statement. You'll need a group, and with the introduction of identity domains, you'll also need to specify which identity domain. And then you'll need a action verb, which specifies, what level of access this policy is giving to that group. And you'll also need a resource type. So on this slide here, we're targeting compute instances. Last but not least, you'll need a location. So where do you want to attach this specific policy statement to? Which compartment is it? You'll be able to add that into your policy statement. So as you can see, policies are in human readable format. And as Sunil mentioned, these policies can only allow access. They cannot deny it. And let's go ahead and take a look at policy syntax and what that looks like. So here we have an example of what policy syntax looks like. So at the beginning, you have your identity domain and your group that you're targeting. And then you have your action verb that you'll need to specify. So these are the different types of verbs you can use with different types of access for each. And then you'll also have to specify, your resource type. So you can specify any of these within your policy statement. And then at the end here, this is also where you can add a where condition to make your policy statement more granular. If you want to, specify resource ID, compartment ID, that's where you would put that in your policy statement. So next, I wanted to just look at identity and access management as a whole. We've kind of gone over one part of it. So it really is broken down into 4 main buckets. So we have inbound authentication and SSO, identity store and lifecycle management, outbound authentication and SSO, and last but not least, Oracle Cloud IAM policies. So starting with inbound authentication, This is how users are authenticated into the service. And we have different methods, including inbound federation. So this is either from other identity providers using federation protocols like SAML or OpenID Connect, or even from social providers like LinkedIn, Twitter, and etc. We also have native authentication, of course. So you have different options for MFA, and you also have adaptive security as an option. So this allows us to evaluate session context in real time. So you're looking at factors like, is the user's device trusted? What network or location are they coming from? And their recent behavior as a user. And next, we have our identity store and lifecycle management. So this bucket is really about getting user accounts into the service, managing their attributes, role, and group memberships, assigning permissions, provisioning and deprovisioning accounts, automating the synchronization, and setting security policies. So you can always manage users and entitlements directly in the console, but it's also really common for customers to want to automate things like that, like account provisioning, deprovisioning. So we have several ways to do that. You can automate account management from Active Directory using our AD bridge. And you can also use the provisioning bridge to manage accounts for virtually any enterprise apps that may be running on-prem or cloud-hosted, but they don't support open standards. And if you want to automate provisioning from another identity system or maybe a service management system, you can leverage our APIs or the SCIM protocol to facilitate these types of integrations. And we also have outbound authentication and SSO. So after we know who the user is and what permissions they have, this is how we enable single sign-on to target applications. So we support open standards and protocols like SAML and OpenID Connect, but standards-based federation leaves out a lot of applications. So to combat that, we have an app gateway that enables SSO to enterprise apps, which may be running on-prem or in cloud-hosted environments, but they do not support federation protocols. So instead, it supports HTTP header-based authentication. And then for web apps that actually don't support either of those options, we also offer password vaulting and form fill to simplify the user experience. We also have a radius proxy that allows authentication for databases and VPN clients, and a Linux PAM module that supports SSO to Linux hosts running on OCI. And last but not least, we have our IAM policies at the top. So these allow you to manage access to OCI resources, such as networking, compute, storage, analytics, and more. And just to emphasize that, all permissions are going to be denied by default. So this is where policies come into play. You have to create them in order to allow access where it's appropriate. All right, so now we'll move on to data protection and just how we have different levels of data protection provided by default in OCI and what they look like. So we have a few different types here. We have block volume, file and object storage, and also database. So for block and file storage, the data is going to be encrypted at rest and in transit. And you do have the option to secure your data using the Vault service and bringing your own keys to encrypt. And then for object storage, the data is encrypted at rest, and you're able to bring your own keys as well. There's also the option to create private and public buckets in object storage. You can also utilize pre-authenticated requests for different buckets and objects, which these pre-authenticated requests will provide a URL that has a certain expiration date, but it still allows users to access that bucket or object without having to use their own credentials to do so. And then lastly, for database, Oracle database, we use transparent data encryption, or we call TDE, to encrypt data at rest. And there are also options Oracle provides, such as Data Safe and Data Vault, to help secure your data, which we'll talk about just in a few seconds. All right, so next we have OCI Vault, and I'll talk about what this is real quick. So OCI Vault is a managed service that lets you encrypt all your data using keys that you're able to control yourself. Vaults are essentially logical entities where you can create and durably store your keys and secrets. You can also create virtual private vaults, which is an isolated partition on a hardware security module. And then keys will be logical entities that represent one or more key versions that contain cryptographic material generated from a specific algorithm that lets you use key for encryption. The key encryption algorithms that the Vault service supports includes the Advanced Encryption Standard, the Rivest-Shamir-Adleman algorithm, or RSA, and the Elliptic Curve Digital Signature algorithm. So you do also have the option to bring your own keys if you don't want an Oracle-generated key. And you can also use secrets, which are credentials like passwords, SSH keys, and authentication tokens used to access OCI resources. Lastly, we'll talk about OCI Data Safe. So Data Safe is a fully integrated cloud service focused on the security of your data. So it provides a complete and integrated set of features for protecting sensitive and regulated data in Oracle Cloud databases. So main features include security assessment, user assessment, data discovery, data masking, and activity auditing. So we'll go over all of those briefly so that you get an idea of what these are. Security assessment helps you assess the security of your database configurations. So it analyzes database configurations, user accounts, and security controls, and then reports the findings with recommendations for remediating activities that follow best practices to reduce or mitigate your risk. User assessment, this helps you assess the security of your database users and identify those high-risk users. So it reviews info on your users in the data dictionary on your target databases and calculates a risk score for each user. Data discovery helps you find sensitive data in your databases. So how it works is you tell data discovery what kind of sensitive data to search for, and then it goes ahead and inspects the actual data in your database and its data dictionary, and then returns to you a list of sensitive columns. And by default, data discovery can search for things like identification, biographic, IT, financial, and etc. Next, we have data masking. So this provides a way for you to mask sensitive data so that the data is safe for non-production services and purposes. So for example, if your org needs to create copies of their production data to support development and test activities, you don't want to actually copy the production data because that might expose sensitive data to new users. So to avoid security risks, you can use data masking to replace the sensitive data with realistic but fictitious data. And last but not least, we have activity auditing, and this lets you audit user activity in your databases so that you can monitor database usage and be alerted of unusual database activities that occur. All right, so I will hand it off to Sunil now.
So I'm going to start off with Oracle Cloud Guard. Oracle Cloud Guard is a service that is going to help you take the large amount of data that is collected on OCI, process it, and form recommendations to help you either achieve or maintain strong security in Oracle Cloud infrastructure. For the way CloudGuard works in general, it's going to have three main things it does. The first one is it's going to be examining targets. So when you invoke CloudGuard, or let's say you haven't started using CloudGuard yet, and it's something you're interested in. And by the way, CloudGuard is completely free. The only thing you have to do is type in CloudGuard into the search bar on your tenancy and click enable it to say that you want CloudGuard to be active. So once you say that you would like CloudGuard to be active, you can choose where you would like CloudGuard to target. That's where it's going to process the data coming in on OCI to do the second two things, which is detecting problems and applying responses. CloudGuard is going to be a recipe-based tool where you will take a look at the preset recipes that Oracle has cooked up. You'll see which ones apply to your tenancy. You can choose the criticality and severity of those. And CloudGuard, whenever one of those problems are triggered, create a problem in the CloudGuard UI, where then either you can have CloudGuard, in some cases, apply a remediation, which is going to be a programmatic response to the problem, or you can have you or whoever your CloudGuard administrator is go and look at the problem and then fix it manually. So for targets here, CloudGuard follows the same structure that most services on OCI do. For compartments, they follow compartment inheritance. So we see in this node tree, which are representing compartments, these highlighted compartments is where the target is. So we set our target here, and CloudGuard is going to trickle down and monitor this compartment, and this compartment. If we had put our target in the root compartment, then it will monitor the entire tenancy. Detectors are the CloudGuard components that are going to identify the issues with resources, user actions, and create the alerts when found. So some examples of these, and these are kind of like the recipes we were talking about earlier. You see public instance, public bucket, Tor browser login. These are all common problems. It's usually pretty rare that you want a public-facing instance, and it's exceedingly rare that you would ever want someone to be logging into your environment from the Tor browser. After the detector has been triggered, a problem will be created, and then responders are going to be the last step. As stated earlier, two types of responses. Number one, remediations. You see here, stop instance, suspend user, disable buckets. These are some examples of the different remediations on CloudGuard. There's a handful more that we'll take a look at in the demo in the console. But for some things, let's say it's not as concrete, it's not a binary solution. Let's say the access to restricted ports rule is broken. Then you're going to have to go and check your network, see what ports are open, close the ones that you don't want to be open, and then mark the problem as fixed. Here we'll walk through an example flow. What's going to happen here is a user is going to be creating a bucket. They're in a little bit of a rush, and they've forgotten to click the private bucket flag during creation. This is going to go against the security policy of the tenancy. So now CloudGuard is going to detect this, and a problem is going to occur. The rule bucket is public is going to be triggered, and the problem is going to be created. Next, we're going to have a responder recipe. Depending on your system, you might be using OCI events. And if OCI events is enabled, there's two different ways this could go about. Number one is a function. And the function, let's say in this case, could just make the bucket public. If the function has been written and it fixes the problem, then the flow ends here. If you're not using functions, and maybe you are using functions for some problems and you're not for others, whatever the case may be, if you're not using functions, then a notification will be sent out. The notification will be sent out to the CloudGuard operator. The operator, in this case, might choose to remediate the problem. We saw that there is a remediation for make bucket public. So if the operator did just want to click the remediate button, then the problem would be fixed and the flow would stop here and we would go back to green. However, the CloudGuard operator does not want to use the remediate. Let's say he wants to see who created the bucket. He wants to see where it was created, just to try and make sure that in the future can send out a message, try and let people know not to have this happen again. So they're going to go in and do it manually. When they do that, the responder is going to manually make the bucket visibility private. And at this point, the bucket is now private. The risk has been avoided and CloudGuard is not going to bother you about it. Next, we have security zones. When we looked at CloudGuard just now, we saw that there was different recipes. We saw that it would let someone know something was wrong, and then you could come in and fix it. And there might be a remediation where someone could fix it real fast, but you might think to yourself, this whole system seems very reactive. And to that, I would say you're correct. Security zones, on the other hand, is a much more proactive approach to security. This is going to be the same rule-based, recipe-based tool, except this time, security zones are going to be operating in the control plane. So if someone tries to break the posture of a security zone, the operation is going to be stopped in the control plane. It's not going to go through. Maximum security zones is the Oracle maximum security recommendation for a certain security zone. That could be a compartment. That could be a compartment and its child compartments, whatever you would like. But the thing that you should remember about security zones, because on pen and paper, it sounds like a no-brainer. It's like a security zone. It makes sure that everything is enforced. That sounds really great. And it is very convenient, but there is the also one catch in that it's not flexible. This is not a malleable tool. You cannot cheat. You can't give one instance a certain privilege that the security zone says no to. It's not flexible, so you should only use this if you're certain that all the resources you want to use in that security zone are going to follow the same privileges. However, if you do have that precedent set, then it's a fantastic tool. So, question for you, Winnie. Can you walk me through some of the differences, advantages, pros, and cons of CloudGuard versus security zones?
Yeah, so as you talked about earlier, CloudGuard, it is more of a reactive approach to, what's happening in your environment. But with security zones, you're taking a very active approach to just make sure that, access is not able to come through. And, you can't really change that with security zones. So it's more, what's the word I'm looking for? Absolute. When compared to CloudGuard.
Gotcha. Thank you. So moving on, we're now going to look at LCI vulnerability scanning. Vulnerability scanner is going to help you identify risks on your virtual machines, bare metal hosts, and container images. And the vulnerability scanning tool is built on industry standards. So we based it off of MITRE, CVE, OVAL, CIS benchmarks, and etc. So Winnie, can you walk me through when you're using the vulnerability scanner? What's it actually doing to scan your compute instances? How is it looking for these vulnerabilities?
Yeah, so the vulnerability scanning service, it utilizes 3 different types of scans. So we have host scanning, port scanning, and container image scanning that, they obviously scan different things, but this is what the service utilizes when it does scan for vulnerabilities. And it also is looking at OS and package versions and indexes those against a list of known vulnerabilities.
That's right. So the vulnerability scanner is going to look at your OS, it's going to look at your packages, and it's going to create this threat matrix where it's going to look at these known vulnerabilities from these different industry standards and compare it to what it finds when scanning your environment. So next, we got the web application firewall on load balancers. Web application firewall, easy to use. It's going to be policy-based. You have different subscriptions for different types of traffic you'd like to block. You can use this internally or externally. It works on public and private load balancers. Another interesting thing is that if you do just want to try this out, see if it's something useful, there's actually no charge for your first web application firewall instance, up to 10 million requests a month. So what you can do is simply set one up, try it out for a day or two, see if it seems useful. If it does, you can continue to use it. If you're not getting 10 million requests a month on an application, then you can just use it forever for free. So the idea behind the web application firewall is to restrict controller access to your web apps, data, and services. And what it's going to do is it's going to hide your origin server and inspect two-way traffic. So it's going to inspect inbound and outbound traffic. It's going to try and identify whether requests are from humans or machines. And then it's going to try and filter out bad bots and bad actors and let in the good bots and people who are actually trying to use your web app for the intended purpose. Next, we got OCI certificates. This is going to be automated integrated certificate management and renewal. It's going to simplify the process to create, deploy, and renew your private certificates. There's support for FIPS 140-2 level 3 HSM. You've got support for cross-regional replication, asymmetric keys. There's also many more certifications that are supported in OCI certs. The next one we're going to take a look at is the OCI Bastion. OCI Bastion is a good tool. The idea with the Bastion service is to eliminate cost, deployment, and management pain of jump hosts. So if you've ever made a Bastion host, you know that you've got to have a compute instance or a VM. You got to make sure that you keep your keys secure. You got to pay for the compute space, etc. Also, if you're running low on addresses, having a permanent host does mean that you're going to need to take a reserved IP address for it. With the Bastion is free. It's ephemeral, so it'll just choose one of your IPs from your remaining address pool. It doesn't take up a permanent one. And when you open up the Bastion, everyone can connect where they need to. And by default, the Bastion will spin down after 2 hours. If you want to make it an even smaller window to make yourself a little more secure, you can tweak that window. And you've essentially got a free Bastion host. So here we are in the OCI console, and we are going to take a look at CloudGuard. So here we've got our security score. Our overall security rating is good. Our risk score is 6565. So this score right here is an average of all the resources in your tenancy. This score here is additive. So it's going to take different risks. It's going to add them up with 9,999 being the most the risk score could be. So this would imply that we have, while on average our security is pretty good, there are probably a couple of critical vulnerabilities in our tenancy. As we can see here, we do see that, there's a couple high, but there does seem to be quite a few critical, even though most things are either minor or good. So in the problem snapshot, we can see the different risk levels in our tenancy. We can see the responder status. We can see where the user activity problems are coming from on this map. We see here that there's a little flag in the middle of the North Atlantic Ocean. there's not actually any problem coming from here. Some problems are created as a result of API calls or services that don't have a user and a location attached to them. And so all of those problems are just lumped under this flag in the ocean. So here we can quickly go to security recommendations. We'll click view recommendations. And for the compartment we're in, there's no recommendations. That's my compartment. Good job, me. We're going to click the root compartment. And it's going to give the top 10 recommendations. These are the most critical issues meant to have the highest impact. So we see here, we've got some load balancer SSL certificates expiring soon. Those need to be rotated. Admin group has too many members. Check to see if everyone in the admin group should actually be an admin. This ties back into the IAM security we talked about earlier. Something important with IAM is to remember that the more users that have privileges, the greater the risk of rogue accounts. If every account on your tenancy has access to prod, then every time an account gets compromised, it's not going to be looking too good because they have access to everything. If only a couple people have access, let's say 5%, then most of the time when an account gets compromised, it's not going to be as big of a deal. You might have dev get ransacked, but it is far better than losing people's data. So we'll take a look now at some of these recipes. First, we'll quickly do the responder recipes. We'll see here that there's OCI responder, and then there's some custom ones that we've cloned. The OCI managed recipe has everything on. It's got all the rules, but if you want to make your own and take out some stuff you don't think that's useful, you'll click that clone button we saw. Go back to in a second. You can choose to not use any of these. So we see here, delete IAM policy, delete internet gateway, delete public IPs, disable IAM user, etc. These are all programmatic responses. So if one of these 10 responses fixes a problem, then you'll have the option to use that remediation. And so we see here with Vision Corp. Now we can highlight these and just disable stuff that we don't want, which you can't do in the Oracle managed one. Detector recipes. We see here we have the 3 Oracle managed ones. Sorry, 4 Oracle managed ones for workload protection, threat detection, configuration detection, activity detector. So we're going to look at configuration and activity. For the most part, threat detector, this is just attempting to detect rogue users. Very simple. For workload protection, we see here we've got some stuff about Splunk, RPM. Chef is not installed or running as expected. So it's looking at different dependencies. Configuration detector, this is where most of the problems are going to be found. So we see here, write log access disabled for a bucket, a VNIC without associated network group. VCN security list allows traffic to a restricted port. VCN security list allows traffic to non-public port from all sources. And so we'll see here, we can actually edit this rule, it's flexible. And we can see that we have the restricted port list right here, which you can change, you can expand or decrease as you would like. And so here we see scanned host has vulnerabilities, open ports, etc. Instance is publicly accessible. And so we have a couple pages of these. And if we see when I click these 3 dots, I click edit, we see that it's enabled, and that's all we see. I can't do anything else, right? But if I go back to these detector recipes and I check a configuration detector that I created, we'll now see when we go into something, I'll just choose something random. We see here we can tweak the risk level, or if we don't like the rule, we can just can it. So the kind of end goal of working with something like CloudGuard is that you take this large amount of data that is really hard to process and you trim it using this tool and process it so that ideally when CloudGuard tells you something, it's something that you want to know about, and it's something that would usually take you more effort or more work to figure out on your own. And that's how you can tweak the rules, the risk levels to really mold CloudGuard into a dynamic tool that can save you a lot of time and headache. For activity detectors, these are going to be when you create something. So VCN deleted, VCN created. A lot of networking rules to let you know if someone is fiddling with your network. Tons of stuff for IAM. We have instance being terminated. That's another one. And similar to last time, if you're in an Oracle managed list, everything is enabled and you can't change the risk level. But if you think that for your workload, what we've recommended is not adequate or it's not perfectly in line with your expectations, then you can disable and enable rules as you would like and change the criticality. So with the last couple minutes before our final Q&A, I'm going to quickly pull up security zones as well. So we see here we got security zones. Let's click the overview. And so we see here there's no security zone created, and I don't want to lock anyone else out of anything they might be doing, so I'll go back to my compartment. And we will create a security zone. We'll use the Oracle managed one. So this is going to be the maximum security zone. We'll label this test zone and we'll create it. And so now we'll click the recipe. We'll take a look. We see here, deny image without a sanctioned image, use only configurations approved by Oracle, deny instance in security zone and subnet not in security zone. If someone's trying to get a little sneaky and try and shift things outside of a security zone so it won't be monitored, it's going to block that. Deny block volume in security zone attached to instance not in security zone. Someone's trying to take an instance, detach the block volume and reattach it to something outside of the security zone. That is no good. And so we see here we've got a lot of these sort of things. Deny instance in security zone launch from boot volume not in security zone. Same deal. Not just can the boot volume not go out or the block volume not go out, they can't come in either. Deny public subnets. Deny internet gateway. So if you do want to have some semblance of, deny rules, then this is how you would get them. You can have these security lists with these deny rules in the control plane. And if you don't like all the rules, same deal with CloudGuard. When I was creating the security zone, you'd click the customer manage one, and then it will give you all those different options. You can change the rules. There's no criticality level because the security zone is binary. You either have the rule on or you have the rule off. But that's a real quick look at security zones and how you would use them.
Awesome session. Thank you, Winnie and Sunil. Really appreciate your time and help with this session. I hope it was a good learning experience for everyone. And thanks everyone for joining.